Hey guys, so this video is going to go over physical versus chemical properties as well as physical and chemical changes. So before we can talk about what physical and chemical properties are, let's first define the word properties. So a property is a quality, a characteristic that a substance has. So a characteristic that a substance has that is observable. So a characteristic that is observable. Okay, and when we have physical properties, thank you, Wyatt. Physical properties are observable without changing the thing itself. So observable without changing the substance. Yeah. Wyatt, you can't get up right now, buddy. And so we have examples of these. These are kind of, I guess, things that you can observe with your five senses. So things like luster, malleability, ductility, odor, state of matter, solubility. I'll write some of those things down here. Luster, that's how shiny something is. Malleability, that's like how bendy it is. Odor, how something smells, how something tastes. Again, all these things are with your five senses. What state of matter it's in. So if it's a solid, a liquid, a gas. And then finally, solubility, which is a substance's ability to dissolve in water. So if it, like for sugar, I could take sugar and it'll dissolve. Well, that's a physical property of water. Okay, and then we have chemical properties. So chemical properties are only observable during a chemical reaction. Don't mind my son. Yeah. All right, RXN means reaction. So chemical properties are only observable during a chemical reaction. So for example, something like flammability, flammability. So I can look at, say, a metal table and a wooden table, and I know that the wood is more flammable than the metal. But if I didn't have any life experience, I can't really look at it and know. The only way I would know that the wood is flammable is to light it on fire and see it go up in flames. So it's only observable, when it's happening. So only observable, during the chemical reaction. Whereas these guys over here, they're observable without change. So it's, I just can look at something and it's shiny. And so I know it's luster, at least comparatively to something else. So a couple other things here. We have flammability. What else do we have? We have toxicity. We have pH, which is how acidic or basic something is. We have its reactivity, which is how reactive it is. So, for example, sodium metal is really reactive with water. That is a quality that it has, its ability to react with something, and it's a chemical property because I can't see it unless I put sodium and water together and bonds get broken and things get rearranged. And then a special kind of reactivity would be something ability. Which means it's reacting with oxygen in the air. All right. So those are our physical and chemical properties. Now we have physical versus chemical changes. So obviously a change is a change in the substance itself, whether it be it looks different, it's a different size, or it got mixed with something else. Those kind of things are physical changes. Whereas if it changes its identity, then that would be a chemical change. So a couple like kind of rules, I guess you can say, for physical changes would be that the atoms do not rearrange, meaning there's no chemical reaction. So no rearrangement of atoms, which means there's no reaction. And that also means that the same substances are there both before and after. I'm going to put the same ingredients before and after. And my example for that would be like a big rock. If I have a big, huge, I don't know, say a boulder, it's a big boulder and it's made of, you know, whatever it's made of, and I can smash it. And then it's little tiny pieces of the big boulder, but it's still the same material. We didn't change it at all. So it's the same, you know, ingredient. We wouldn't call it a boulder. We would call them rocks, but it's still made of the same thing. Physical properties the physical properties may change. So think about if I have what's a good example? Okay, let's say my bike. I take my bike out for a ride. It's brand new. It's real shiny and gorgeous. And I ride and I ride and I ride, and you know, month after month, and now it's not as shiny. There's no chemical reactions happening. I kept it in my garage. It didn't get exposed to the weather, but it's not as shiny. That's a physical property. Its luster changed a little bit. So its physical properties may change. Bless you, Wyatt. Thank you. All right. And also, it's generally easy to produce. So if my bike's not as shiny, I can polish it up and, you know, boom, that shiny comes back. All right. So now let's talk chemical changes. A chemical change means that a chemical reaction occurred. So a chemical reaction occurred. I think that I spelled occurred wrong. So just ignore that and we're going to pretend it didn't happen. Because I apparently don't know how to spell it. Whew, excuse me. Okay, so chemical change occurred, meaning the atoms are rearranged. Via a chemical reaction. We can write chemical equations. So say, for example, you know, I have element A chemically bonded to element B. So that's compound AB. And then they separate and they become element A and element B. A real life example of this would be sodium chloride. So NaCl, that's table salt. It's edible. It's, you know, delicious. You put it on your French fries. However, if we decompose sodium chloride into sodium metal and chlorine gas, sodium metal is very dangerous. It's a soft metal. It's very reactive with water. Chlorine gas, it can kill you. It's this green noxious gas that can literally kill you. So it changes its identity. It breaks bonds, makes bonds, and, you know, often produces energy. So things like that. Just a quick kind of review about this chemical equation here. So the left side of a chemical equation, what I started with, those are the reactants, and that's something that I need you guys to be able to identify. And then over on the other side, these guys are the products. They're what was made, what was produced. And as long as you know that, you know, those atoms rearrange to form new bonds, things like that, it should be good to go. And so that's chemical versus physical properties. Yay! All right, we got